Good evening, ladies and gentlemen, and a warm welcome to our second Highland Branch Royal Aeronautical Society webinar of 2022 on building the UK's first vertical launch spaceport. My name is Kirsty, and on behalf of the Highland Branch Committee, I'm delighted to welcome back Society members, those joining us for the first time, and those who have watched our previous webinars. We'd like to know who we have joining us, so please use the chat to introduce yourself and tell us where you are from. During the webinar though, if you could keep yourself muted, that would be much appreciated and just ensure a smooth delivery of the presentation. Before we begin, we would like to emphasise that we are entirely a volunteer-run organisation. So if you are sitting there thinking you have great ideas or think you can bring something to the committee and would like to get involved, please do get in touch as we are looking to expand our branch. Throughout tonight's presentation, I invite you to ask questions in the chat, which will be answered at the end, or alternatively, save them until the question and answer session at the end, where you can raise your hand using the webinar's function before I will ask you to unmute your microphone, turn on your video if you wish, and interact with Scott and ask him yourself. We are very fortunate to have Scott Hammond with us this evening. After a very impressive career in the RAF, flying the Tornado GR4s for 19 years, he moved on to fly the A320s from Heathrow before returning back to the RAF as the Chief Instructor on the GR4 simulator. Now he is Operations Director for SaxaVord. This evening we will hear all about new space and why Shetland is the best place to launch from. Scott will then go on to explain the challenges of building a spaceport and then describe the range, what it is, and how it is monitored. Without further ado, I'm delighted to pass you over to Scott Hammond.
Thank you very much, Kirsty. I'm rather hoping that I'll be able to. I think you're still. Are you presenting still, Kirsty?
I shouldn't be.
Okay, I'll stop doing that. See if I can take control. Start again. And has that entered to PowerPoint presentation mode, Kirsty?
Yes, it's all good now.
Lovely, great. Well, it's always good to start with a IT faff. Thank you very much, for the Highland branch of the RAeS for inviting me to talk. It's a real pleasure to come and tell you a little bit about what we're up to up in Shetland. I'm sure a number of you will be aware of what we're doing. A few of you perhaps are coming here for the first time, and maybe some people have even visited Unst, which is the most northerly island in the UK. When you're standing on the launch site itself, we often get people to have a photo taken because at that point they are the most northerly person in the United Kingdom. So what I'm going to try and talk to you today is about what we're doing and how we're building the UK's first vertical launch spaceport. I always like to start with this quote, mainly because, of course, it makes me look important. But this is a chap called Peter Beck, who is the CEO of Rocket Lab. They are a small rocket launcher down in New Zealand. They launch up to 150 kilograms into sun-synchronous and polar orbits. And he had to develop both the rocket itself and the spaceport. And this is his quote: "If you think developing a rocket is difficult, try building a spaceport." Clearly, I totally agree with him. And I think the fact is that when you're building your own rocket, you are master of your own destiny. You have a very set process to go through. You work your way through the problems, etc. When you're building or trying to develop a spaceport, you have so many third-party entities, governmental, private, etc., that interact with you that you're very rarely the master of your own destiny. We have to get airspace changes, we have to look at maritime, we have to look at health and safety, you have to look at coma. all in addition to actually building and getting planning permission for a spaceport. So there's a huge amount of bits and pieces that interact with us that make it so much of a challenge, to be quite honest. So what I'll aim to talk to you about is I'll start with what is new space, and some people refer it to Space 4.0. It's also sometimes called the democratization of space. Then we'll talk about the orbits and missions that new space is particularly involved and interested in. And then we'll talk about Shetland. Why is Shetland such a good location, and why Scotland is such a good location? I'll then talk a little bit about Launch UK, which is the UK government and UK Space Agency's programme to get the UK to be launching rockets and satellites into space, and talk a little bit about the Pathfinder launch, which is a UK Space Agency contributed through grant through Lockheed Martin to a company called ABL Space Systems, who will be launching from Shetland in Q4 of this year, and that will be the first vertical launch from the UK and we hope from the European mainland. I'll then talk a bit about building the SaxaVord Spaceport and all of the challenges that are involved with that. And at the end, I'll talk about what else we do, that we're not just a launch site. So while I'm talking about SaxaVord Spaceport, we also are Shetland Space Centre, and that's very important. We are already active in space, and we can discuss a few things that we are already doing. And at the end, I'll have some questions. So I'm going to start with a video by a company called Astra, who are an American launch company that can launch about 150 kilograms to sun-synchronous orbits, and they'll talk a little bit in this video about their ideas and what they want to get up to in space. I did notice some of the faces on this are probably a little older than me, and I'm 58. Have a look at how young some of these people are.
There's a revolution happening in space. Small startups are launching a new generation of satellites made from off-the-shelf parts smaller than a loaf of bread, manufactured in days, not years. These satellites are watching over our changing planet, helping farmers grow the food we need, connecting billions to the internet, and ensuring a safer world. The only problem has been affordably and reliably launching these satellites into space. Until now. What if you could depend on a launch every month, every week, every day? What if booking a launch was as easy as booking a flight from San Francisco to New York? Our mission is to provide the first daily space delivery in history. We're building rockets that are 50 times smaller. We're building 50 times more of them. And we're getting to orbit faster than ever before. You decide when you go, what's on your rocket, what orbit you're going towards, and we'll do the rest. We're the world's largest space company that you've never heard of.
So lovely stuff. I think you can tell from that, you know, this is it's an old industry doing new things with new people. So it's very much now commercial. Previously, it was old space, putting very large satellites up into generally geostationary orbits, really, you know, governmental, billions of dollars, etc. Now it's all about giving access to space for commercial activities. And these companies, the small satellite companies, they want to get to space as soon as possible, and they want to get to where they want to go rather than have to go where the traditional big rockets take them. Now, it's not just the commercial part of it. ESA, and even though we have left the European Union, we're still a member of ESA, as is, for instance, Canada. They've also recognised that there's a big change going on in space, and even the ministerial meetings talk about what they refer to as Space 4.0. And this is an emergence of companies and participation, industry and citizens, and the whole global interaction. And you can read it all there. But they also seem to think this is like the fourth industrial revolution. So it's very much of the now. It's being driven by young, very talented people who have a great vision of what they want to do. And it is, very much the future. I personally, at my age, am absolutely delighted to have the chance to be a part of this. But I'm very aware that my part will only be for a few years, as all of these young people come from behind to actually make this reality for the whole of the human population. So what sort of orbits and missions are we particularly interested in here in Scotland and Shetland? Well, for us, they are polar orbits and sun synchronous. You can see on the right-hand side an indication of orbits. So the geostationary orbit, that's pretty typical for something like a GPS type satellite, out about 36,000 kilometers. And for that, you really do want to launch from close to the equator, and we can explain why in a bit. But where the commercial interest is very much in the polar orbits and the sun synchronous orbits. Sun synchronous are a type of polar orbit, and what they do is they will cross the equator at the same local time each time they go across. So you've always got to think that the orbit stays in the same place and the Earth is rotating underneath. So the satellite will go around about once every 90 minutes. So every time it crosses the equator, let's say it's 12 o'clock at local time whenever it goes past. And the reason for that is they're interested in change. And a good example would be if they went at different times of day, some of the change might be shadows from interpreted. Equally, if you went over and you're interested in traffic and you want to go over at 9 o'clock in the morning, you want to do that consistently so as you can look at the changes that are going on. For the pure polar, they tend to be far more communications, and a good example of that is the Starlink that are being put up by SpaceX to give 360 coverage of the Earth for internet. So those are very much the types of satellites and the missions that we aim to support. But why Shetland? Well, it all comes down, much as where you live, to location, location, location. So as I said, if you want to go to geostationary, generally you want to be close to the equator and you want to launch heading east. And the reason for that is the Earth spins towards the east, and at the equator, while we all do 360 degrees a day, at the equator you are traveling faster. And you can see on the left-hand side, that's about 1,650 kilometers an hour. So when you're launching geostationary or out to the moon, that is free energy that you do not need to use fuel to gain. And that throws you out and you can get up to those orbits. However, if you want to go into polar orbit, if you were to launch from the equator, you would have to get rid of that energy that is throwing you out to the east. And that takes fuel. The more fuel you use, it's actually now the impact on the payload. So just as in an aircraft, we have a maximum takeoff weight, which is made up of, as we probably all know, of the dry weight of the aircraft, then the fuel and the payload. It's the same with a rocket. So if you want to maximize your payload, you want to reduce how much fuel is on board so as you can maximize the payload. If you're at the equator, you have to use more fuel, so that reduces how many kilograms of payload you can put into orbit. The cost of fuel, not dramatic, but some firms quote up to $30,000 per kilogram to get up into space. So you can see if you maximize that payload, you maximize the profitability and the economic sustainability of that particular launch. So where we are, we're at about 1,200 kilometers an hour, and clearly you could carry on all the way to the pole where you'd have ideal from Earth rotation. The next thing you need to look at, though, is actually where you're flying over. So on the right-hand side, you can see a typical launch from Shetland with a two-stage rocket. This would probably be three-stage, in fact, with a first-stage impact point, fairing impact point, and a second-stage impact point. And you can see that is a direct line. You do not want to overfly any areas of population, because there is a danger clearly that the rocket could fail and explode and debris could come down, or the rocket could just stop. Actually, the engines could stop, and it would just be a normal ballistic type rocket that would come down. And clearly, that would be very bad if it came down in any population centres. Equally, those areas where you know bits are going to come down, you need to make sure those are not in populated areas. So for us, it's a direct line, which means just as you're doing a great circle route as you go across the Atlantic, again, it minimizes that fuel. If, for instance, you're in another location, you may have to call what's called a dogleg, fly what's called a dogleg, and that would actually use more fuel. Yes, the cost of fuel is not dramatic, but it's the impact on the reduction in the payload that's the thing that sort of really bites you. So for us, and again, anybody who's been up to us on a cold winter's day, you will know there's nothing between us and the Arctic. So it's great from our point of view. We have a low rotational velocity, and B, a really good area over which we fly with no population centres, which allows us to get the greatest payload to orbit for the least amount of fuel. And that's what it comes back down to. It is all commercial. About Scotland now, Ivan McKee, he is the space minister, and you can see here, you know, very well. Hopefully, it's becoming more, people have become more aware quite how many satellites are made in Glasgow. We've got a number of great satellite manufacturers in Glasgow, and it's really punches well above its weight. So already the UK and Scotland is, you know, a big player in space. Across the other part of the central belt, we've got Edinburgh, and in Edinburgh, they are really, really good at interpreting that space data. And here's an example of one of the companies, a company called DCAT, based in Edinburgh, who look at standing water, and they can then help with agriculture. So between these two cities, already Scotland has a very, you know, vibrant space industry. But what we haven't had up until this point is launch, or the ability to build rockets. And that's very much what Launch UK is all about. So Launch UK, this was started at about maybe 2015 sort of thing, a UK government initiative. And the UK government was looking around and saying, you know, what are the industries that we should be supporting? Where is the growth? Where are the high paid jobs? And they identified, you know, that space was an area where the UK was already doing pretty well, as already described, with satellite and satellite data. But what we didn't have in the value chain was launch, building the rockets and actually launching the rockets themselves. So the UK government set itself a target and gave it the target to the UK Space Agency to win 10% of the global space market by 2030. Now, that is quite a challenging number. You know, there's no denying that. But if you don't give yourself something worthy of, you know, attempting, then, you know, it's a bit worthless setting something. So that's what they're trying to do. So what they then said is, okay, how do we kickstart and get that launch industry going in the UK? And they decided from that what they'll do is a UK vertical launch program, and that was initiated back in 2017. And they were looking for launch sites and launch manufacturers to become what they are calling the Pathfinder launch, the very first vertical launch from the UK. And they put about £25 million of the taxpayers' money into it. Initially, that was in Sutherland with Highland Branch Enterprise. But back in about 2019, Lockheed Martin, who were the launch provider, decided that they wanted to move, and they moved to us here in Shetland. And since then, we've been working really hard with Lockheed Martin on the design of the spaceport and all the other aspects, which I'll start to describe as we're moving on, to achieve that Pathfinder launch in 2022. You can see, you know, those are the numbers. You know, we already earn good money from the space industry, but there's far more to be made out there, and the UK really is in a great position to benefit from space. You know, whether you are happy with Brexit or not, the UK is a good place to do business. We have, you know, the rule of law. You have contracts which people can adhere to. We have proper regulations. We have great insurance. So actually attracting people to operate from the UK is very, very well, not very simple. It is simple, but we now need to make sure we have that whole value chain. So as we can have a satellite made in Glasgow, a rocket made in perhaps Edinburgh, launched out of Shetland, data comes down into Shetland, and the data goes to Edinburgh, and there it is then analysed and goes to the customer. So very much everything happening in one legal sort of entity. So that's all about new space and what the UK government wants to do. So what are we doing here at the Shetland Space Centre? Well, first of all, we're going to give the UK a sovereign launch capability. Now that we have launched into space from Australia before, back in the 70s, but since then we've done nothing. This will now give the UK its own launch site and access to launchers that we can then put satellites that we make or customers from other countries up into space and then bring much needed valued jobs to the whole of the UK, Scotland and Shetland. What I must though stress here is, I know you've had a talk from Highlands Islands Enterprise about Sutherland before. The difference between the two is we are a commercial organisation, so we don't have any government money behind us. We've raised all the money from private investors, and that means that we're very much focused from a commercial aspect on making sure that we're going to build a sustainable business that's going to bring sustainable jobs, and we're going to make a profit. So we're not going to end up being a white elephant. So there is no public money in us. To do that, we need to make sure that we have a business model that is, wash its own face. So what we're looking to do is build a generic spaceport. So it's not a spaceport for just one launcher. We will have up to maybe up to 5 different launchers operating from our site. And that means that those launchers and rockets don't have to support all of the spaceport's startup costs on their own. And the spaceport startup costs will involve things like doing an airspace change, which costs between £500,000 and £1 million to do. So if it's just one for one rocket, they have to be able to cover all of that. But if you've got 5, they can all spread that cost. We can also start to share facilities, much as when you go to Heathrow. British Airways don't have their own runway. They share it with all the others. Yeah, some of the terminals, yes, they've got their own, but it's shared. So it means that that infrastructure is not being laid onto one operator. That will lead to cost reduction for the companies that come to us, and it also means that from our point of view, we are not beholden to a single operator. So if for instance, we had maybe Prestwick Airport, and our only company coming into us was Ryanair, they really could hold us to ransom. So we need to make sure that that is not the case. The other thing we can do by having this diversification of rockets is we have a diversification of rocket capability. So just as at Heathrow, A380s and A320s land, we will have rockets launching from us with a capability of launching 150 kilograms up to 1,200 kilograms. And the important thing from our point of view, is we don't necessarily know exactly where the sweet spot in the market is going to be. So being able to cater for all types within the small rocket sort of gambit, it means that wherever that sweet spot is, we are going to be able to cater for that. And that again comes back to that sustainable business model, making sure that we spread risk and we make ourselves as sustainable as possible. Those of you who've been to Shetland will already know the great connectivity we have up there. Been supporting oil and gas for about 40 to 50 years. So we have pre-COVID 27 flights a day coming into the airport from various parts in Scotland and the UK, and 2 overnight ferries arrive every day carrying cargo and passengers. The port of Lerwick moves 1 million tons of cargo a year. So really, really good established industrial base. And that means that we're already bringing in a lot of the commodities, liquid oxygen, liquid nitrogen, helium, etc., that are used in the space industry is already coming in, and we can just sort of piggyback onto those supply chains. Diversified business, I've talked about diversifying between rockets, but we'll talk a little bit more about other parts that we're going to do. So we've got a couple of ground stations we're operating, which are bringing data down from space, and we're looking at doing some space situational awareness, all again down to our great location. Space tourism, in this case, I'm sorry, it's not people going to space, but it's people who will come up and visit the site to see what's going on, and hopefully, you know, view some launches. And that's clearly going to bring some business to the island, in particular the B&Bs, the coffee houses, etc., etc. So what we have been trying to do is design that spaceport that's going to allow for safe, and safety is the #1 priority. But we have to be safe and achieve a high launch cadence, and we're going to do that by having concurrent operations on site. So not just one operator on site, 3 to 5 operators on site at the same time, doing their work so we can get that high launch cadence. And very much, and I guess this is where of interest to the people, you know, in this particular society, we are going to be operating this spaceport very much as an airport. And that's, you know, our background. Our background is generally aviation. And to be quite honest, there's not much difference between a spaceport and an airport. The only thing is we don't tend to have people coming back to land. It's a one-way trip for us. So this is the easy bit. This is what the site will look like in about 2 or 3 years' time. We will have 3 launch pads, the roads going out to them, and then we'll have 3 integration hangars, which is where the rockets are put together, mated with the satellites, and we'll then have a number of satellite tracking areas, which will track the rockets as they're going up into space, and bring down the data from them so as we can learn to improve on any future launches. So the actual building of a spaceport is pretty simple. You know, you've got some concrete pads. You have to have areas for fuel, and a lot of them just use kerosene, Jet A1. Areas for things like liquid oxygen, and then you have a integration hangar, which is effectively a small industrial building, some overhead cranes in there, some clean rooms where the satellites are mated to the upper stages, and then the satellite tracking. So not really complicated. So this bit is relatively easy. The difficult bit, though, is building a commercially sustainable spaceport, which has to be safe. How do you do that to make sure you can be regulated and licensed when, and we began back in 2017, none of the regulations exist? Now, there was a lot of chat within the UK Space Agency and the CAA, who have now become the regulator, as to what they were likely to do. But they were very much in the learning process because the UK has never done it. So how do we go about saying, OK, we're going to have the pads there, the hangars here, this is how we're going to run things, when there are no guidelines and regulations that we can look to? And we also need to think, well, okay, well, what is the government's risk appetite and strategy? How much risk is the government prepared to accept for, you know, an industry that is, you know, it is pretty challenging. Things do go wrong. How much is the government going to, you know, cover on insurance, and how much is pure commercial? And you need to build that into all of your design, because your design can make you far safer and therefore easier to insure, but you need to have that sort of you know, balance between the commerciality. So what we did is say, okay, what we need to do is identify examples of good practice around the world, and the best example for us really was the US. So the US have got a whole load of regulations, and they're put out by their Federal Aviation Administration, I'm pretty sure the A is, and they're under CFR 417 and 420, and they describe how you operate, build, design, etc., a spaceport. And we have the backing here of the UK regulations, because they actually do say that when we're looking to reduce risk to ALARP, if there are examples of good practice and standards, and we can show how they'll benefit, we can use them. And in particular, if they're already written down and well defined and well established. And we come back to the Americans. So they have been established in about 1995. So, you know, almost 30 years now, during which I think they've had 45 or so. Well, this industry calls them anomalies. We don't have accidents. So things have gone wrong. But in that time, no member of the public has been injured. So that already gives you an indication that these regulations have stood the test of time. So that's what we decided. We will look at the American regulations and we'll take those as our template, and then we'll try and build and UKize them, because the UK and the US do have subtly different definitions of risk. And the example is societal or collective, and how the US sees things is slightly different to how we do. One of the things the US does do, which we don't, is they give numbers, expected casualties, etc. So, you know, for them, it's 1 to 10 to the -4 for launch, also for re-entry. Now, here in the UK, we don't do that. Yes, we have an idea of what our risk appetite is, but it is up to us, the developer, to design something that is ALARP. So it needs to be as low as reasonably practicable. So if we get it to the tolerable region, we don't just stop there. We need to say, okay, what else could we do? And if we did do that, is it too expensive, too difficult, doesn't bring to that much of a benefit? So very, very similar again to the aviation industry. And this is what the regulator will be looking at, is they'll look at how we're going to operate, have we brought everything back to ALARP, and then we need to tell the story of how we have designed the site, how we're going to run the site, and use examples from CFR 420 to back up why we are doing that. You can see, you know, other countries also have very, very similar sort of risk appetite. So, you know, the UK is not an outlier, but the Americans give numbers people have to hit, while here in the UK, it's a story you have to tell to show ALARP. There are a number of licenses. You can't just go out and launch, sadly, from your back garden. So the spaceport, that is one license, and you can see the various things that we have to do to meet that. Safety clear zones, safety sighting assessments, which I'll talk more about. Then you have the launch license, which is the rocket manufacturer. They have to do flight and ground safety analysis, environmental security. So, you know, got those. Then you've got the range license, and that is again going to be us here in Shetland, and that is where we monitor the sea space and the airspace through which the rockets are going to fly en route to space. You then have an in-orbit license, and that's for the satellite operators. And they again have to go to the for them it's the UK Space Agency. For the previous three it's the Civil Aviation Authority. And then finally you can have a rocket operator permission, which comes under the ANO. And here in the UK they use the definition of the stratosphere, which they've defined these days at 45 kilometers in altitude. And if you're not going above that, then you can launch a small rocket, which is not going to enter orbit. It'll be suborbital, so it'll go up to about 45 kilometers and then come back down to the Earth's surface. That is again done by the Civil Aviation Authority, but is not part of the Space Industries Act. So here in Shetland, we're going to get the spaceport license and the range license. All right, let's try and get down into a bit more of the, you know, how do we go about it? So safety clear zones. How this industry operates is it does things through exclusion. Now, we had a look at all of the emergency plans for Sunbury Airport and the multi-agency response plan, etc. And the thing about those plans is there are people at risk, and so how you react to an emergency is very different to us. For us, once we start fueling a rocket, we will put into place a safety clear zone, and nobody will be allowed in there. So if there is a failure, let's say a fire, we won't necessarily go in and fight that because there is no risk to life. We'll just let it burn out. And that's a complete mindset change from aviation. And so when we're sort of looking at our ConOps and everything and talking to outside agencies like the fire service, we have to explain how we are going to do things differently. And it all comes down to that we will exclude people from an area where hazardous operations are going on. The UK didn't have any of that. So again, we go back to the Americans, and they, in their CFR 420, they then start to talk about TNT equivalent. So you look at a rocket and it's now got Jet A1 on board, a whole load of liquid oxygen. What does that mean in explosive potential? What you do is you actually calculate, you add them all together, and you say 20% of that is a TNT equivalent. And then that starts to give you blast zones. And what you're interested then is all of the damage mechanisms of those blast zones. So the first one is heat. That doesn't go out very far. The next one is overpressure up to 1 psi. That doesn't go very far. And the final one is fragments. And fragments coming with a certain kinematic power at you and a certain size, and how those are going to injure you. And that's what drives a lot of these safety clear zones, because those fragments are going to be thrown some distance. But we also look at intraline, and intraline is very much you don't want to get a ladder effect in an explosion. So very much as the RAF, when they put their bomb dumps in places, they make sure if one bomb explodes, it doesn't set off all the other bombs. It's the same with how we set up the pads. So what we do is we look at the rocket and we say that rocket has got, let's say, 100 kilograms of fuel and liquid oxygen on it. That gives a fragment distance of 100 meters. We then say, okay, do we have other fuel and liquid oxygen within that distance? Yes. Therefore, we go back and do the calculation again. We have the 100 kilograms I spoke about on the rocket, and we add all of the other fuels and liquid oxygen nearby. And they tend to have, if they're going to need 100 kilograms to go for one launch, they'll have 100 kilograms ready to go. So that tends to double that safety clear zone. And that's how you start to work out what is the area you need to secure to make sure that you maintain safety. This is an example from one of our launch pads here in Shetland. The white line shows you the area of land that we control, and that's important. So that land belongs to us. Outside of that are, farmers with sheep, etc., etc. This is a safety clear zone, and this has been calculated against the very largest rocket that we will get licensed for. And I'll talk about the definition of a small rocket as we move on. But that gives you this large safety clear zone. And the important thing here is you can see that it remains within the land controlled by Shetland. If that safety clear zone went into somebody's third-party land, then we would have issues, because we cannot control their part of land and stop people going in. So it's really important that we have that capability and the power essentially to control those safety clear zones. The next thing is a siting assessment, and this is set out in the UK regulations under number 41. And what it is that you need to show that where you have decided to put your spaceport is the safest place that you could possibly choose. So could you launch from the middle of London? Yes, but it just wouldn't be safe. So you need to look at where are we going to site the spaceport and the launch pads to make sure that their impact on safety for the public is minimized to as low as reasonably practicable. There are two ways to do this from the American regulations. You can do actual calculations, or you can go into their regulations, and you can work out through going through various tables what the risks are, potential casualties, etc., etc. The first thing you need to do, though, is look at what class of rocket you're going to launch. Now, here in the UK and in Shetland, we are going to be launching small, and that means that to 100 nautical mile orbit, in this case, 28 degree, 90 degree inclination, we can launch about 1,500 kilograms of payload. So it's not the size of the rocket, it's the capability of the rocket. And that will be the largest rocket that we will be launching here from Shetland. So immediately, once we go into the small, then we start to be given numbers from the documents there of how far we need to make sure people aren't and where they could be in danger. And one of the ways you can do that is to actually do a full flight safety analysis. Now, this one was done for a potential spaceport, which I think is just getting planning permission over in the States, Camden. It's down the east coast of the US in one of the southern states. And the reason they had to do that is, you can see on the left-hand side, they're actually overflying some people's houses. So what they needed to show that is the risk to those people was for the Americans less than 1/10⁻⁴ for any particular launch. So what they do is they look at the rocket and they say, okay, rocket goes up, rocket explodes. How much explosive power is there, and what sort of debris will start coming out from that rocket, and how far will that go? Clearly, the higher you go, the further the debris could go. But because this is all probability based, if the higher you go, the debris goes further, but now there's less particles per meter squared. So if you were standing in the open, the chance of you being hit starts to go down. So although it's going up, at some point the probability of you being harmed starts to come down. And that's what you can see on the right hand side, is that, close in, there's a higher probability, but as it goes up, because those potential debris is further spread out, there's less chance of you actually being harmed. And this, as I say, this was done by Camden Spaceport. You can go online. It is freely available, and you can see how they go through all the calculations. So they have prediction of failure, etc., etc. This, is quite an undertaking. The other way to do it is to go into the regulations and take the advice of how they have actually calculated by looking at a whole load of different flight safety analysis. And all of these numbers are backed up by their DoD explosive documents, etc., which talk about explosive potential, fragments, etc., etc. And what they come back and they say is, okay, you have to have an overflight exclusion zone. Here in the UK, we call it different. We call it a launch exclusion zone, but it is based at the launch point, and we use a Dmax of 1.2 nautical miles. So you have a 1.2 nautical mile radius around the launch point, and then in the direction of the trajectory, you have 3.3 nautical miles until you have another separate point, and then you have another 1.2 nautical mile area. That gives you that exclusion zone. And during a launch, no ships, no aircraft, no people are allowed in there. And that makes sure that you get below the 10⁻⁴, 10⁻⁶ as appropriate within the American regulations. But that's just close in. You then need to look at the flight corridor. And with the flight corridor, you then look at just to 1.2 nautical miles uprange, and then you start to look downrange, and it starts to then come out to one side, and then it's working its way on all the way to the downrange area. And you notice the area goes up to 5,000 nautical miles. For us, that is over near Hawaii. So it's a pretty large area. But for us in Shetland, we're only interested out in what we call the launch area, which is out to 100 nautical miles. And what we do then is we look at population within that, and then we can do calculations to see the risk to the population. So bringing it back down more to specifics, we are going to be launching from 330 degrees true to 030 degrees true, and that gives this potential maximum. I'm saying overflight exclusion zone, but we call it launch exclusion zone. For individual launches, it will look more like the lozenge, but that gives you straight away the area that we would be excluding people from. And the important thing is nobody lives in there. There are no occupied houses in there. There's no population in there. So that automatically means that we don't have to exclude people from those areas who already live there. But we have to control it when we actually do launch. So that's all relatively close in. The next thing we look at then is that expanded flight corridor. And what we can see here is we've done from 330 to 030. 330, there is nothing out there in the North Sea. But as we come further to the east, we start to come towards where a lot of the oil rigs are. Now, even on 030, there's still some distance away from our trajectory, but we still do the calculations to see what is the potential of any debris potentially landing on them. And from that, then we can go back to the UK Space Station, CAA, and say, we are intrinsically safe where we're launching because we are bringing down that risk as low as reasonably practicable. If we then bring it closer in, you can see how they both combine. This would be for a typical sun-synchronous launch from Shetland. You can see the launch exclusion zone, and then you can see the flight corridor. Now, within the flight corridor, there are some occupied houses. And so we know most of them by name, to be quite honest. So we know that we might have 20 people in there, and then we can do the calculations to say, okay, there are 20 people in there, but that is still safe. We're not going to clear those people out, but we need to make sure that what we're doing is intrinsically safe for that population. And that's really the beauty of our location, is that low population density means that, we are, in a safe position. We then go on to the range. Now, if you can have Heathrow Airport, if you haven't got the air traffic to get you in and out of there, all you've got is a strip of concrete, very similar to a spaceport. You've got to have the airspace and the sea space over which you are going to fly to get into space. And how you define it, and we saw a little bit earlier, you're going to go into those regulations of 420. And what they say is you have to go out to 5,000 nautical miles from the launch point, which, as I said, is Hawaii, or where the continuous computed impact point leaves the Earth's surface. And that means at that point, nothing's coming back. Well, it will eventually come back down a little bit, burn up. So, any potential debris is going to stay up in space. Now, this is the great thing. And when you get involved in space, you start thinking, wow, this is cool, because of the speed that these things are doing. So let's, one example is noise. So a rocket launching from Shetland gets to 60,000 feet in about 60 seconds. So you've got a minute of noise, haven't you? No, because when it gets to 6,000 feet, it takes another minute for that noise to get back down to you, roughly. I know there'll be some experts listening in. So that means you hear it for 2 minutes. And it's all to do with the speed of its movement and distance. It's the same with the range. So for us, when a rocket, its CCIP leaves the Earth's surface, it's probably going to be just south of Greenland, so about maybe 600 kilometers north of where we are. So that sounds fine. But the forward throw at that point is south of Alaska, because it's going so fast. So even if it, let's say at 599 kilometers, it failed, the parts would start to come down potentially in Alaska. So that's how you've got to think. You've really got to think globally. When you're building a spaceport, you cannot think, okay, my little kilometer around me. You've got to think, where do we fit into the globe, and what effect will launching from us have on other parts of the globe? We then got to think who and what is at risk. So on the right hand side, you can see where the exclusive economic zones are. So there's a chunk of it is the UK. Great, we can drop bits into there, and we have to go through UK regulators. But we might be dropping parts into Norwegian zone, or into Iceland zone, or into international waters. So all of that has an impact. And so what we'll need to do is put out notice to mariners to say, there's a danger of parts coming down in this area at this time, don't go in there. And we have to go through all that regulatory process. For this audience, clearly airspace. So, as we're flying up through that, we're going through Reykjavik FIR, potentially into Bodo, Oceanic, etc., etc. And so we need to interact with them. And we do know that stages will be coming back down. So we need to NOTAM those areas to make sure that pilots and the customers are kept safe from these fairly large bits of rocket coming back down to the Earth's surface. So that's, really, is a big thing for us. Clearly, there's the little bit of land that we're involved in. And one of the things that I've had to design for Shetland is our sheep plan, to how we're going to move the sheep when we launch. Because all the crofters, it's really valuable to them. But that's part of the land side. So we've got that land, air, and sea that we need to monitor, control, notify people, look at the safety aspects of it for just one launch. Airspace, we are going to do an airspace change, and we're doing it through the CAP 1616 process. To get a permanent, that takes about 2.5 years. Ours, we just paused. We're about to get it going again. And at the moment, we're also doing a temporary. So we will have a temporary danger area for those first launches. And we do that by going through the whole process with the CAA. It is quite torturous, to be quite honest. Somebody from the CAA on board, but it is a process we have to go through. We have to consult with various airspace users, people on the ground, etc., who may be affected to get that airspace. But that is only the airspace around the spaceport. The drop zones, etc., will be NOTAM'd. And that sort of pie area you can see, that will not be closed off. That is just showing you the area where there is a potential hazard. The actual area that will be closed off for orbital launch mainly be, a 5 or 6 nautical mile circle, because the rocket will be up through 100,000 feet within about 2 or 3 kilometers of our launch site. And when it's through there, it's beyond air breathing aircraft. But we do need to think about drop zones. So what we've done, and I'll concentrate here on airspace, we did look back in 2019, pre-COVID, to look at the amount of air traffic north of us. So we've got some heat maps. Heat maps always look bad because the pixel size has to make something out so as you can actually see it. So unsurprisingly, there's some traffic that goes along Norway, the Norwegian coast, goes out to the to the oil rigs and back, and then we've got a sort of route that goes just to the north of Shetland. However, we then look at the difference of what time of day, in week, etc., height and everything, and that we can then identify actually how much traffic is actually out there. And we did this with a local company to Aviso, and they got all ADS Bravo data for the whole year, as I say. And from this, we can see in general, it's sort of transatlantic type traffic. You can see in general, it's about midday. And when we look at the density, it's 3.31, within, that area, per day. So it's a really, really quiet piece of airspace. That doesn't mean we're not going to have that airspace change, and we might look to maybe reroute to the south. But the fact is, where we're aiming to overfly at the moment is already very, very quiet. And we did exactly the same for ships. For instance, we looked at one of the drop zones and we said, okay, May the 12th, how many ships were in that drop zone? Couldn't find any. We had to go a week either side to find one ship that even got close. So again, it's, the beauty of our site is that the areas that we're overflying and potentially dropping stuff in are already very, very quiet. But we don't want to just be a launch site. Launch is challenging. There will be peaks and troughs in income. How do we keep our people engaged, busy, etc.? So what we need to do is look at what other things we can do. And the big thing I'm going to concentrate on here is satellite tracking stations. So, every time in orbit, you've got the satellites going around, they're going over the pole, and they go round about once, every 9 minutes, about 16 times a day. Clearly, the height will affect how quickly they're going. So if you were at the pole, you would see that satellite 16 times a day. You could interact with that satellite. You could bring down the data, and that would be a great thing. Difficult area, though, to operate from. Even more difficult to get the data out, because it's all very well the data coming down, but it's got to go to the person that is paying for it. So we need to be as high latitude as possible, about 70 north for us, something like that. Sorry, 60 north, and have good connectivity. So we've got a super fast, high speed, about 10 gigabyte or so fiber optic cable that comes all the way up to our site, which means that the data that comes down into our ground stations can go straight down that to the people that are paying for it. And when we've done all the calculations, and you can see what we've done here, we will interact with a satellite 600 kilometers about 12 times a day. So that means that we get 12 opportunities to bring the data down. It also gives 12 opportunities to talk to the satellite itself and say, your next job is, or what is your serviceability state, or start to move your solar panels because you're running out of power, etc., etc. So it's that interaction with the satellites. We've had our ground station up there for about 6 months now. We've supported launches out of Alaska, out of Cape Canaveral, and out of the European Spaceport down in Kourou. So again, our location, that high latitude, it comes back to we are already operational. We are already doing stuff with spacecraft, with rockets, with satellites. This basically shows you again, not only the amount of times you see it, but it's how long you see it. The longer you see it, the more data you can get down. Although it has to be said, as we move into the higher frequencies, the data download or the amount of data can speed up, but it's still important. The longer you can see it, the better. This gives you an idea of the types of ground station we've got. So they work in S and X band, although we are looking at getting some Ka, Ku bands, and also in VHF and UHF. So the smaller satellites, the CubeSats, tend to work in the VH-UHF, and then about the 250 kilogram satellites we expect to be in the S band. So our satellite dish sits up there 24/7. It waits. It knows that a satellite's going to come over, so it turns to look at the satellite. It then locks onto the signal from the satellite, and it tracks that satellite, bringing down the data and from horizon to horizon. Once it's done, it puts it back into the park position and waits for its next. And we will be bringing these out. We'll probably have a few more in Shetland. We're going to also bring them out in other parts of the world, Greenland, Alaska, etc. So we have a network around the globe. So hopefully I haven't taken too long. I'm quite happy to take any questions. It's a bit of a run through, the SaxaVord Spaceport and what we're doing in Shetland. It is very, very exciting, and we rather hope that you're all as excited as we are, and looking forward to that launch in Q4 of this year. So I'll shut up.